Somewhere in ancient Mesopotamia, a scribe pressed a reed into wet clay and recorded something that had no explanation. The rivers had turned bitter, the sky had gone dark for days, the dead outnumbered the living, and the sun, when it finally returned, looked different than it had before. That tablet is still in a museum in London. Half a world away, in ancient Egypt, a different scribe writing in a tradition that stretched back further than most people alive today would believe described a civilization coming undone. The Ipuwer papyrus, dated to somewhere around 1850 years before the Common Era, reads like a transmission from the edge of collapse. The land turns around as does a potter's wheel. The towns are destroyed. Upper Egypt has become dry wasteland. Scholars have debated for generations whether this text describes a real event or a literary metaphor. What they cannot explain is why it matches, almost line by line, accounts written by people who never could have read it. In the Norse tradition, before the gods themselves fell, there was a winter without a summer, 3 years of cold, 3 years of darkness, crops that would not grow, animals that disappeared from the land. They called it Fimbul winter. The skald who first recorded these stories was not writing fiction. He was writing down the oldest memory his culture still carried. The Aztec world was built on a cosmology of catastrophe. They did not believe this was the first sun, the first age of the world. They believed there had been 4 suns before this one. Each of them ended by a different kind of destruction. One ended in flood, one ended in wind, one ended in fire raining from the sky. They built entire civilizational systems around the certainty that this sun too would eventually end. And then there is Plato, writing in Athens around 360 years before the Common Era. He described a story he claimed to have inherited from Egyptian priests, who told it to a Greek statesman named Solon. The story was already ancient when Solon heard it. It described a powerful civilization, wealthy and technologically advanced by the standards of its time, that vanished beneath the sea in a single day and a single night. Plato placed this event at approximately 9,000 years before his own time. That would put it at roughly 11,360 years ago. Mesopotamia, Egypt, Scandinavia, Central Mexico, Greece, by way of Egypt. 5 cultures, 5 separate languages, 5 separate belief systems that developed on different continents, with no documented contact with one another at the time these traditions were formed, and they all described the same day, not symbolically, not metaphorically, with specific details: fire from above, a darkened sun, rising water, the sudden disappearance of the world as it had been known. For a long time, historians called this coincidence. They called it the universal human fear of nature, expressing itself in similar shapes across different cultures. That was a reasonable explanation, and for most of the 20th century, it was the accepted one. Then the scientists started digging, and they found a layer of evidence buried beneath the soil on 4 separate continents. A thin, dark line in the earth. Platinum. Nanodiamonds. Tiny glass spherules that could only have been formed at temperatures found in one of 2 places: deep inside a star, or at the point of a cosmic impact. The layer is 12,900 years old, and it is everywhere. Before we go further, if you have found your way to this channel, and this is the kind of story that makes you want to stay, welcome. This is the space for history that is patient, for questions that do not have clean answers, and for the kind of knowledge that takes time to settle in. If you feel like this is where you belong, consider subscribing and turning on the bell, so these stories find you when they are ready. And now, back to the silence beneath the soil, and what it has been trying to tell us for nearly 13,000 years. For most of the 20th century, the transition out of the last ice age was understood as a slow, gradual process. The glaciers retreated, the temperatures rose, the megafauna either adapted or disappeared over the course of thousands of years, and human civilizations eventually emerged from small hunter-gatherer bands into the complex societies we recognize from recorded history. It was a clean, comfortable narrative. It fit the dominant scientific framework of gradual, incremental change, the idea that the Earth moves slowly and that catastrophe is the exception rather than the rule. Then geologists started looking more carefully at what the ice itself was recording. Deep inside the Greenland ice sheet, there is a kind of frozen archive. Every year, a new layer of snow compresses on top of the last, trapping inside it tiny samples of whatever was floating in the atmosphere at that moment in time. volcanic ash, pollen, ocean salt, and occasionally, things that have no business being in the atmosphere at all. When scientists drill down through those layers and pull out ice cores, they are reading a continuous record of atmospheric history that stretches back hundreds of thousands of years. Each layer is a year, each year is a page, and one particular page, sitting at a depth that corresponds to approximately 12,900 years ago, contains something that took decades to fully understand. The temperature record shows a drop, not a gradual cooling, a sudden, severe and sustained drop in average temperatures across the entire northern hemisphere, beginning within what the ice record suggests was less than a single human lifetime, and persisting for approximately 1,200 years. Scientists call this period the Younger Dryas. It interrupts the warming trend of the last deglaciation like a door being slammed shut. Before it, the world was warming steadily. After it began, it was as though a switch had been thrown. Forests retreated, tundra expanded. The great megafauna of the northern hemisphere, woolly mammoths, mastodons, giant ground sloths, and American horses, short-faced bears began disappearing at a rate that the fossil record had never previously recorded. For a long time, the leading explanation was climate stress combined with human hunting pressure, and those factors almost certainly played a role. But they did not explain the timing. They did not explain why the collapse happened so rapidly, or why a specific moment in time, not a century, not a millennium, but a geological instant seemed to mark the boundary between the world before and the world after. In 2007, a team of researchers led by geophysicist Richard Firestone of the Lawrence Berkeley National Laboratory published a paper in the Proceedings of the National Academy of Sciences. The paper presented evidence of a thin layer of material found at dozens of sites across North America and Europe that sat precisely at the boundary of the Younger Dryas onset. Inside that layer, researchers identified platinum group elements at concentrations far above background levels. They found nanodiamonds, microscopic crystalline structures that can only form under conditions of extreme pressure and temperature. They found tiny glass-like spherules, formed when rock or soil is heated to the point of vaporization and then resolidifies as it falls back to Earth. And they found a charcoal layer indicating a biomass fire of a scale that has no modern equivalent. The layer became known as the Younger Dryas boundary, or the YDB layer, and in the years that followed that initial paper, the evidence for it did not shrink, it expanded. By the time researchers like James Kennett of the University of California, Santa Barbara, and his colleagues published follow-up studies across the next decade and a half, the YDB layer had been confirmed at sites on 4 separate continents: North America, Europe, the Middle East, and most recently, South America and South Africa. More than 50 sites, all of them sharing the same distinctive chemical and physical signatures, all of them dated to the same narrow window of time. The hypothesis that emerged from this body of evidence, now known formally as the Younger Dryas impact hypothesis, proposes that approximately 12,900 years ago, one or more fragments of a disintegrating comet entered Earth's atmosphere and either impacted directly or exploded at low altitude in what scientists call an airburst event. The energy released would have been orders of magnitude greater than any nuclear weapon ever tested. The fires ignited across the northern hemisphere would have consumed millions of square kilometers of forest. The dust and soot thrown into the atmosphere would have partially blocked sunlight, triggering the cascade of cooling that the ice cores record. The animals that survived the initial fires would have faced a rapidly deteriorating food supply. The human populations that witnessed it would have had no framework, scientific, religious, or otherwise, for what they had just experienced. They would, however, have remembered it, and they would have told their children. What remains unexplained is the precise mechanism and the exact source. The Younger Dryas impact hypothesis has been contested seriously and rigorously within the scientific community, which is exactly how science is supposed to work. Some researchers argue that the platinum concentrations are consistent with volcanic activity. Others question the dating precision at certain sites. The debate is genuinely ongoing, and it would be dishonest to present the hypothesis as settled fact. What is not seriously disputed is the existence of the YDB layer itself, the reality of the Younger Dryas temperature collapse, and the coincidental timing of the megafauna extinctions. The question is not whether something happened, the question is exactly what it was. Then, in 2018, A team of scientists from the Technical University of Denmark and NASA published something that changed the conversation considerably. Using airborne radar data collected over decades of survey flights, they had identified a structure buried beneath more than a mile of ice in northwestern Greenland near a place called Hiawatha Glacier. The structure was circular. It was approximately 31 kilometers across. Its edges were raised, and its center was depressed in a way that is geologically consistent with only one known process, a meteorite impact. The Hiawatha crater, as it was named, is one of the 25 largest confirmed impact craters on Earth. And while the precise age of the impact has not yet been definitively determined, the ice above it has complicated the dating process. Preliminary analysis suggests the impactor may have struck within the last 800,000 years, with some researchers arguing the evidence is more consistent with a far more recent event. One theory suggests the Hiawatha impactor could be related to the Younger Dryas boundary event, a fragment of the same disintegrating body that scattered destruction across the northern hemisphere. This remains unconfirmed. But the existence of a crater that size, beneath the ice sheet at the precise latitude from which the YDB evidence is most concentrated, is not something that can be set aside. Step back from the technical details for a moment, and consider what all of this means when placed alongside those ancient texts. The Ipower papyrus describing a sky that turned dark, the Norse Fimbulwinter, describing 3 years without a summer, the Aztec memory of a sun that ended in fire falling from above, the ancient Mesopotamian records of rivers gone wrong and populations vanished. These traditions did not emerge from nothing. They were not invented by people with nothing better to do. They were preserved, generation after generation, through oral tradition and eventually through writing, because the people who first witnessed these events understood in whatever language and conceptual framework they had available to them that what had happened needed to be remembered, that the sky had done something it should not have done, that the world had broken in a way that had to be passed forward. And now, buried in the ice of Greenland, and in the soil of 4 continents, and in the frozen chemical record of a catastrophe that happened 12,900 years ago, there is a record that confirms what they were trying to tell us. The myths were not metaphors. They were the only archive that survived. There is a hill in southeastern Turkey, roughly 12 kilometers northeast of the city of Şanlıurfa, that for most of human history looked like nothing in particular. The stones that occasionally pushed up through the surface were assumed to be the remnants of a Byzantine cemetery. Unremarkable, unworthy of serious attention. A survey conducted by the University of Chicago and Istanbul University in 1963 noted the site and moved on. The hill sat undisturbed for another 3 decades. In 1994, a German archaeologist named Klaus Schmidt arrived at that hill and recognized something the earlier surveys had missed. The stones were not Byzantine. They were not grave markers. They were the tops of massive carved pillars, buried deliberately, waiting beneath centuries of accumulated soil for someone with the right eyes to find them. Schmidt began excavating the following year under the auspices of the German Archaeological Institute. What emerged over the next 2 decades of careful, methodical work was something that did not fit inside any existing model of human prehistory. Not at the edges, not in minor ways. It did not fit at all. Göbekli Tepe. The name translates roughly to Potbelly Hill in Turkish, is a complex of circular and oval enclosures, each one ringed with large T-shaped limestone pillars standing up to 5.5 meters tall and weighing between 10 and 20 tons. The pillars are carved with detailed reliefs of animals, foxes, lions, vultures, scorpions, aurochs, cranes, spiders, and serpents rendered with a technical precision that implies not an early experiment in art but a mature and practiced tradition. Some of the pillars bear humanoid features, arms carved along their sides, hands resting at the abdomen, suggesting they may represent stylized figures of beings that held meaning within whatever belief system organized the community that built them. The dating of the site is where the ground shifts beneath everything we thought we understood about the ancient world. Radiocarbon dating of organic material found within the construction layers places the oldest enclosures at approximately 9,600 years before the Common Era. That is 11,600 years ago from where we stand today. To place that in context, The Great Pyramid of Giza was built roughly 4,500 years ago. Stonehenge began construction approximately 5,000 years ago. The earliest known writing system, the Sumerian cuneiform, appears around 5,300 years ago. Göbekli Tepe predates all of them by a margin that is not modest. It predates the pyramid by more than 7,000 years. But the age of the site is not the most disorienting part. The most disorienting part is what the people who built it did not have. According to the conventional archaeological timeline, the community responsible for Göbekli Tepe lived before the Neolithic Revolution, before the systematic cultivation of crops, before the domestication of animals for food, before permanent settlement, before pottery, before metal tools, and before writing. They were, by the definitions we have used for most of modern archaeology, hunter-gatherers, people who moved with the seasons, people who, by all prior assumptions, lacked both the social organization and the surplus resources necessary to undertake a construction project of this scale. To quarry, transport, carve, and erect pillars weighing up to 20 tons without the wheel, without draft animals, without any of the organizational infrastructure we associate with complex society, and to do this not once but across dozens of enclosures over a construction period that may have spanned several centuries, requires a level of coordinated human effort that, until Göbekli Tepe was dated, we did not believe existed at this point in history. Archaeologists have estimated that the construction of a single enclosure would have required the sustained labor of hundreds of people working in organized shifts, fed and coordinated by some kind of administrative system that left no other trace in the archaeological record. Schmidt spent the last 20 years of his life excavating the site before his death in 2014. Ground-penetrating radar surveys, conducted after his passing, revealed that what has been uncovered so far represents approximately 5% of the total complex. The remaining 95% is still beneath the hill. There are believed to be at least 20 additional enclosures waiting to be excavated. Whatever Göbekli Tepe was, whatever purpose it served, whatever community sustained it, we have barely begun to understand it. What is known is this: around 8,000 years before the Common Era, several thousand years after the oldest enclosures were built, the entire complex was deliberately buried, not abandoned, not left to collapse, buried. The enclosures were filled in with soil, flint tools, animal bones, and stone debris in a process that would have required as much organized effort as the original construction. The pillars were carefully covered, the site was sealed and left, and then the hill sat silent for the next 10,000 years. Archaeologists have noted that the deliberate nature of the burial is one of the most puzzling aspects of the entire site. There is no evidence of destruction, no evidence of invasion, no evidence of environmental catastrophe forcing an abandonment. Something motivated the builders or their descendants to preserve the complex beneath the earth rather than simply leaving it exposed. One theory suggests the burial was a ritual act, a ceremonial closing of a sacred space, perhaps connected to a shift in religious practice or cosmological belief. Another theory suggests the community may have understood that what they were burying needed to be protected across a span of time longer than their own civilization could guarantee. What remains unexplained is why they made that choice and what they believed they were preserving it for. The question of who these people were and where they came from intersects uncomfortably with the timeline established in the previous segment of this story. The oldest enclosures at Göbekli Tepe were being constructed within a few centuries of the Younger Dryas impact event. The communities that built it were living in the immediate aftermath of whatever catastrophe had reorganized the world around them. One theory suggests Göbekli Tepe was not the beginning of civilization, but a remnant of something older, that the organizational knowledge and technical skill it represents had not yet been developed from scratch, but had survived from a prior period, and was being reconstituted by people who remembered, however imperfectly, what a complex society looked like. This remains a hypothesis. It is contested. Mainstream archaeology continues to treat Göbekli Tepe as evidence of a more sophisticated hunter-gatherer culture than previously imagined, rather than as evidence of a lost prior civilization. Both positions deserve to be stated honestly, because the evidence does not yet compel us definitively toward one or the other. What the evidence does compel us to accept is this: our timeline of human complexity is wrong, Not slightly wrong, fundamentally wrong. The capacity for organized religion, monumental architecture, and sustained cooperative labor existed at least 6,000 years earlier than our models predicted. And the community that demonstrated this capacity chose, at some point, to bury the evidence of it beneath a hill in southeastern Turkey, where it waited in silence for 10 millennia until a German archaeologist with patient eyes came along and started asking the right questions. Schmidt once said that Göbekli Tepe was built not by the first civilization but by the last hunters. That framing is poetic and probably partially accurate, but it leaves open a question that the stones themselves do not answer. If these were the last hunters working at the very edge of one world, on the threshold of another, what exactly were they trying to remember? And who did they believe would eventually come looking? Wherever you are listening to this right now, whether you are lying in bed somewhere in the middle of the night, or sitting with a cup of something warm while the rest of your house is still asleep, or perhaps somewhere on the other side of the world where it is already tomorrow morning, drop a comment and let me know. Tell me your city. Tell me what time it is where you are. There is something quietly remarkable about the fact that a hill buried in southeastern Turkey for 10,000 years is pulling people together from opposite ends of the planet in the same quiet hour. The builders of Göbekli Tepe could not have imagined that, and yet here we all are, still asking the question they left behind. Inside Enclosure D at Göbekli Tepe, toward the northwestern edge of the structure, there stands a pillar that has attracted more careful attention than almost any other single object at the site. It is designated, in the dry language of archaeological cataloguing, as Pillar 43. But among researchers who have spent time with it, and among the broader community of people drawn to the deeper questions of human prehistory, it is known by a different name. It is called the Vulture Stone. The carvings on Pillar 43 are among the most detailed and compositionally complex at the entire site. On the lower register, a scorpion. Above it, a cluster of birds. To the right, what appears to be a large vulture with its wing extended outward, as though in the act of bearing something. Beside the vulture, a circular disc that some researchers have interpreted as the sun or moon. And at the center of the composition, a figure without a head, a human form, decapitated, positioned beneath the wings of the vulture in a posture that reads, across the distance of 11,000 years, as unmistakably deliberate. For years, the standard interpretation was that these carvings were religious or ceremonial in nature, representations of death, the afterlife, or the cosmological beliefs of the community that made them. That interpretation is probably not wrong, but in 2017, two researchers at the University of Edinburgh, Martin Sweatman, a scientist in the School of Engineering, and Dimitrios Tsikritsis, a mathematician, published a paper in the journal Mediterranean Archaeology and Archaeometry, proposing something considerably more specific. Their argument, developed through a detailed analysis of the astronomical positions of star constellations as they would have appeared from the latitude of Göbekli Tepe at different points in history, was that the carvings on Pillar 43 are not simply symbolic, they are a star map. And the star map, they argued, encodes a specific date, approximately 10,950 years before the Common Era. The mechanism that makes this possible is a phenomenon called precession of the equinoxes. The Earth does not spin on a perfectly fixed axis. It wobbles. Very slowly, completing one full wobble over a cycle of approximately 25,700 years. This wobble means that the positions of stars relative to the horizon change gradually over millennia, and that means the night sky visible from any given location on Earth in 10,950 before the Common Era looked meaningfully different from the sky visible today. Sweatman and Tsikritsis worked backward through that precession cycle and identified which constellations, as defined by the animal groupings used in ancient Near Eastern astronomical traditions, would have occupied specific positions in the sky above Göbekli Tepe at the proposed date. Their findings were striking. The scorpion at the base of Pillar 43 corresponds, in their analysis, to the constellation Scorpius positioned at the horizon. The cluster of birds above it corresponds to the Milky Way as it would have appeared in that era. The vulture with its outstretched wing corresponds to the constellation Sagittarius near the galactic center. and the circular disk, the sun or moon symbol, sits in a position consistent with the summer solstice sun as it would have appeared on that specific night. At that specific latitude, at approximately 10,950 years before the Common Era. That date falls within the onset window of the Younger Dryas. The headless human figure, in their interpretation, represents a human death, or perhaps mass human death, associated with the event being recorded. The vulture bearing the disc is a common ancient symbol for a soul being carried into the sky. What Sweatman and Cataclysm proposed, carefully and with explicit acknowledgement of the speculative nature of their conclusion, is that Pillar 43 is a memorial, a monument to a catastrophe that the builders had either witnessed themselves or inherited from those who had. A record, carved in stone, because stone lasts, of the night the sky fell. It is important to be honest about where this interpretation stands within the broader academic community. It has not achieved consensus. A number of archaeologists and archaeoastronomers have raised serious methodological objections, questioning the assumption that the animal carvings at Göbekli Tepe correspond to the same constellation figures used in later Near Eastern astronomical traditions, noting that the identification of specific star groupings with specific carved animals involves interpretive choices that are not compelled by the evidence alone. The paper has been cited and engaged with seriously, but it has not been accepted as established fact. What remains unexplained is whether the builders of Göbekli Tepe possessed a sufficiently developed astronomical tradition to intentionally encode precession-based star positions in their carvings, something that, if true, would push the origins of systematic astronomy back by several thousand years beyond any previously known example. What makes the Sweatman and Cataclysm hypothesis difficult to simply dismiss, however, is the convergence of independent lines of evidence pointing toward the same narrow window of time. The Younger Dryas boundary layer, confirmed on 4 continents, dates to approximately 12,900 years ago. The oldest enclosures at Göbekli Tepe date to within a few centuries of that event, and if the astronomical reading of Pillar 43 is correct, the date encoded in the carvings falls precisely at the Younger Dryas onset. 3 independent datasets, geological, archaeological, and potentially astronomical, clustering around the same moment in prehistory. One theory suggests that the builders of Göbekli Tepe were not simply memorializing a catastrophe, but encoding a warning, a record precise enough that anyone with sufficient astronomical knowledge, looking at those carvings thousands of years later, could reconstruct both the event and its timing. If that was the intention, it was an extraordinarily sophisticated one. It would imply that the people who carved Pillar 43 understood precession, understood that their warning needed to survive not just decades or centuries but millennia, and understood that the language of stars was more permanent than any spoken or written tradition they could pass forward. Whether or not that interpretation holds, the vulture still stands in enclosure D with its wing outstretched and its disc held aloft, and the headless figure still lies beneath it in the posture of the fallen, and the scorpion still waits at the base of the composition in the position of a horizon constellation on a night that may have been the most catastrophic in the memory of our species. The stone has been silent for 10,000 years. And the question it raises whether this is coincidence, or whether someone a very long time ago looked up at a sky that was doing something terrible and decided that the only honest response was to write it down in the most permanent language available to them. That question does not have a clean answer yet, but it is exactly the kind of question that deserves to be asked. There is perhaps no story in the entire catalogue of ancient literature that has been more relentlessly pursued, more confidently claimed, and more thoroughly misunderstood than the story of Atlantis. It has been located, by various researchers and enthusiasts over the past 2 centuries, in the Atlantic Ocean, the Mediterranean Sea, the Caribbean, Antarctica, the Sahara Desert, the North Sea, and beneath the waters off the coast of Cuba. It has been called the origin of all civilization, the home of an alien race, and the invention of a philosopher with a political point to make. The signal has been buried so deeply beneath layers of speculation and wishful thinking that it has become almost impossible to approach the original source clearly. So let us begin with what Plato actually wrote. In 2 dialogues composed around 360 years before the Common Era, the Timaeus and the Critias, Plato presents a story that he attributes not to his own imagination, but to a chain of transmission reaching back considerably further. The philosopher Solon, one of the founding lawgivers of Athenian democracy, travelled to Egypt around 590 years before the Common Era and visited the temple complex at Sais, in the western Nile Delta. There, according to Plato, Egyptian priests showed Solon records of a history far older than anything the Greeks possessed. They described a powerful maritime civilization located beyond the Pillars of Hercules, what we call the Strait of Gibraltar, that had existed approximately 9,000 years before Solon's own visit. This civilization had grown wealthy, technologically sophisticated by the standards of its age, and eventually corrupt. It had attempted to conquer both Egypt and Athens before being defeated. And then, in a single day and a single night, it had sunk beneath the sea. Plato gives measurements. He describes a capital city built on a series of concentric rings of land and water, with a central island approximately 5 stadia across roughly 900 meters. He describes a surrounding plain, approximately 3,000 stadia by 2,000 stadia in dimension. He describes a navy of 1,200 ships and an army drawn from a confederation of kings ruling a territory larger than Libya and Asia combined. These are not the vague, poetic flourishes of mythology. They are the specific, numerical descriptions of a document. The first question serious researchers ask is whether Plato invented the story as a philosophical allegory, a cautionary tale about hubris and the corruption of power, or whether he was working from a real source. The honest answer is that we do not know with certainty. Plato was not above inventing illustrative myths to make philosophical points, and he did so explicitly in other dialogues. But he was also unusually specific in his attribution of Atlantis to Egyptian records, and unusually detailed in his geographical and numerical descriptions. Scholars who have studied the transmission chain, Solon to Dropides to Critias, the elder to Critias, the younger to Plato, note that it is internally consistent in a way that fabricated genealogies of sources rarely are. Archaeologists have noted that the temple at Sais was a real institution, with a documented tradition of preserving ancient records, and that Egyptian priestly knowledge of pre-Greek Mediterranean history was genuine and extensive. The 3 most seriously examined candidate locations each offer real evidence and real problems. The first and most academically respected candidate is the island of Thera, known today as Santorini, in the southern Aegean Sea. Around 1620 years before the Common Era, a date established through ice core analysis and the presence of Theran ash layers in Greenland and Anatolia, the volcanic island underwent one of the largest eruptions in recorded human history. The eruption destroyed the Minoan settlement at Akrotiri, triggered tsunamis across the eastern Mediterranean, and almost certainly contributed to the decline of Minoan civilization on Crete, which collapsed within a century of the event. The parallels with Atlantis are genuine. A sophisticated maritime culture, a catastrophic destruction, a sudden disappearance from the historical record. What remains unexplained is the scale discrepancy. Thera was a regional catastrophe, significant but not civilization ending on a global scale, and Plato's measurements do not match the Aegean geography in any straightforward way. The second candidate is the reshaped structure, a geological formation in the Sahara Desert of Mauritania, near the city of Ouadan. Seen from above, the reshaped structure, sometimes called the Eye of the Sahara, presents a series of concentric rings of eroded rock that, in aerial photographs, bear a striking visual resemblance to Plato's description of Atlantis's ringed capital. One theory suggests that the structure was once a coastal or near-coastal site that was inhabited during the African humid period, approximately 11,000 to 5,000 years ago, when the Sahara was a grassland environment with rivers and lakes. Some independent researchers have noted apparent alignments between the structure's dimensions and Plato's measurements. What the reshaped structure lacks, critically, is any evidence of submergence. It has never been beneath the sea, and no significant archaeological remains consistent with an advanced civilization have been confirmed there. The visual parallel is intriguing. The evidentiary basis remains thin. The third candidate is the most geographically ambitious, and, in some ways, the most consistent with the Younger Dryas timeline established earlier in this story. Sunderland is the name given to the large landmass that connected the islands of Sumatra, Java, Borneo, and the Malay Peninsula during the last glacial maximum when sea levels were approximately 120 meters lower than they are today. At its maximum extent, Sunderland was roughly the size of the Indian subcontinent. As the last ice age ended and sea levels rose, Sunderland was progressively inundated over several thousand years, with the final submergence of the Sunda Shelf occurring somewhere between 10,000 and 7,000 years ago. The geologist Aricio Santos spent decades developing the argument that Sunderland was the geographical basis for the Atlantis tradition, pointing to the region's richness in biodiversity, its position in a tectonically active zone prone to volcanic catastrophe, and the timing of its submergence as consistent with Plato's account when the transmission errors of oral tradition are accounted for. The actual bathymetric data of the Sunda Shelf, the confirmed shape of the drowned landscape, does show a large, relatively flat plain surrounded by elevated terrain, now submerged beneath the Java Sea and the Gulf of Thailand. What no candidate location has yet provided is a confirmed archaeological site, structures, artifacts, inscriptions that matches the technological sophistication and historical period Plato describes. That absence is significant. It does not disprove the story, but it constrains what can be claimed. What remains unexplained is a detail that sits quietly at the center of the entire question and does not receive enough attention. Plato places Atlantis at 9,000 years before Solon's visit, approximately 9,600 years before the Common Era. That is 11,600 years ago. That date does not correspond to any known Bronze Age civilization. It does not correspond to the Minoans, or the early Egyptians, or the Sumerians. It corresponds, with uncomfortable precision, to the period immediately following the Younger Dryas impact, the same window of time in which Göbekli Tepe was being constructed, in which the megafauna were disappearing, in which the YDB layer was being deposited across 4 continents. If Plato was faithfully transmitting a genuine Egyptian record, even imperfectly, even with the distortions introduced by centuries of oral transmission and translation between languages, then the civilization he was describing would have existed in the exact period when, according to the geological evidence, the world was being reorganized by a catastrophe of cosmic scale. A powerful maritime civilization, at its height in the period before 12,900 years ago, would have occupied coastlines that are now beneath the sea. Its records, if any survived, would have been preserved only in the oral traditions of whatever descendants made it to higher ground traditions that eventually found their way, by routes we cannot now reconstruct, into the archive at Sais. One theory suggests Atlantis is not a single place, but a compressed cultural memory of an entire lost world. The coastlines, the settlements, the complexity that existed before the sea rose and the sky broke, filtered through thousands of years of retelling into the shape of a single island and a single catastrophic night. That theory cannot be proven, but it cannot be easily dismissed either, and the fact that it aligns, without being forced to, with the confirmed geological record of the most catastrophic period in recent human prehistory, that is not nothing. That is the kind of convergence that deserves to be taken seriously, held carefully, and investigated with patience, rather than either dismissed as fantasy or embraced as certainty. The ocean has not given back what it took, but it has left the shape of what is missing pressed into the seafloor, and the memory of it pressed into the oldest stories our species still carries. Between 20,000 and 7,000 years ago, the world's oceans rose by approximately 120 meters. That number is not a projection or a model. It is measured, confirmed, and documented across dozens of independent lines of geological evidence. Coral reef dating, ocean sediment cores, ice volume calculations, and the direct observation of drowned landscapes that are now visible on the seafloor. 120 meters of vertical rise, accumulated over 13,000 years, translates into a horizontal loss of coastline that in some regions extended hundreds of kilometers inland from where the shore stands today. To understand what that means in human terms, consider this. Modern archaeology has established beyond any reasonable doubt that human populations have always preferred coastal and riverine environments. The evidence is consistent across every continent and every period of prehistory we have been able to study. Coasts offered protein-rich food sources, moderate climates, access to trade routes, and natural boundaries for territorial organization. The concentration of human activity along coastlines is not a modern phenomenon. It is one of the most consistent patterns in the entire archaeological record, which means that the majority of human settlements that existed between 20,000 and 7,000 years ago, whatever complexity existed in that period, were built on land that is now beneath the ocean. And we have barely looked. The scale of what has been lost to rising sea levels represents what some researchers have called the greatest gap in our understanding of human prehistory. Archaeologists have noted that if even a modest fraction of Paleolithic and early Neolithic populations lived on now submerged coastal plains, then the picture we have constructed of early human civilization, based almost entirely on inland sites that happen to survive above the waterline, is not just incomplete. It may be systematically misleading. In the same direction, for the same reason, at every point in the timeline, 3 sites, examined with the rigor they deserve, begin to suggest the shape of what the ocean is hiding. The first is Doggerland. Between the eastern coast of Britain and the western coast of Denmark and the Netherlands, the North Sea floor conceals what was once a substantial landmass, a low-lying plain of rivers, marshes, and forests that connected Britain to continental Europe and supported significant human populations during and after the last glacial maximum. The existence of this landscape has been known to archaeologists since the 19th century, when fishing trawlers began pulling up the bones of mammoths, aurochs, and ancient deer from the North Sea floor. But the systematic mapping of its extent and its human occupation did not begin in earnest until relatively recently. Research led by Bernhard Wenninger of the University of Cologne, published in 2008, combined bathymetric mapping of the seafloor with sediment core analysis to reconstruct the Doggerland landscape in considerable detail. What emerged was a territory of considerable size at its maximum extent. Doggerland covered an area roughly comparable to present-day Great Britain, occupied by Mesolithic hunter-gatherer communities for several thousand years before it was progressively inundated by rising sea levels. The final, catastrophic end of Doggerland did not come gradually. Around 6,200 years before the Common Era, a massive submarine landslide occurred off the coast of Norway, an event known as the Storegga Slide. The Storegga Slide displaced an estimated 3,000 cubic kilometers of seafloor sediment, generating a tsunami that struck the coastlines of Britain, Norway, and the Faroe Islands with waves estimated at between 10 and 20 meters in height. The evidence for this event is confirmed and unambiguous. A distinct layer of marine sediment found far inland across Scotland and Scandinavia, at elevations consistent with a tsunami of the modelled height. Whatever remained of Doggerland above the waterline at that point was almost certainly submerged or rendered uninhabitable within a matter of hours. The communities living there would have had no warning, whether any survived by moving to higher ground, and whether the memory of that sudden catastrophic flooding fed into the broader tradition of flood narratives that appears across European and Near Eastern cultures remains an open question. The second site is in India. In 2001 and 2002, the National Institute of Oceanography of India conducted a systematic survey of the Gulf of Kambat, a shallow inlet on the northwestern coast of the Indian subcontinent near the city of Dwarka in the state of Gujarat. The survey, using side-scan sonar and underwater video equipment, identified a series of geometric structures on the seafloor at depths of between 30 and 40 meters, regular rectangular formations consistent with the foundations of buildings, extending across an area of roughly 9 kilometers in length. Artifacts recovered from the site included worked stone tools, pottery fragments, and organic material that was radiocarbon dated to approximately 7,500 years before the Common Era. If confirmed, the structures at Dwarka would represent organized urban settlement in the Indian subcontinent approximately 3,000 years earlier than the Indus Valley civilization at Mohenjo-Daro and Harappa, which has traditionally been considered the earliest complex society in South Asia. The Dwarka findings have been contested. Some researchers have questioned the interpretation of the sonar imagery, arguing that natural geological formations can produce regular-looking structures that are mistakenly identified as human construction. The dating of the organic material has also been questioned, on the grounds that loose artifacts on a seafloor cannot be reliably associated with the structures near which they were found. What remains unexplained is why the geometric regularity of the formations extends across such a large area in a pattern inconsistent with known natural processes in that geological environment. The National Institute of Oceanography has called for further systematic excavation. That excavation has not yet been fully funded or conducted. The third site is the most visually arresting and the most genuinely ambiguous. Off the southern coast of Yonaguni Island, the westernmost island of the Okinawa archipelago in Japan, there lies a series of underwater rock formations at depths of between 5 and 27 meters that have been the subject of sustained academic debate since their discovery by a local diver in 1986. The Yonaguni Monument, as it is known, presents a complex of flat terraces, sharp right-angle cuts, parallel grooves, and what appear to be staircase-like formations carved into a single massive rock structure approximately 250 meters long and 25 meters high. Professor Masaaki Kimura of the University of the Ryukyus, who spent years diving the site and studying its features, argued that the regularity and geometric precision of the formations are inconsistent with natural erosion and represent evidence of human construction, dating to a period when the site was above sea level, potentially as long ago as 10,000 years before the Common Era. The opposing view, held by a number of geologists, including Robert Schoch of Boston University, who is himself not a defender of conventional timelines, having argued for an older date for the Sphinx at Giza, is that the Yonaguni formations are entirely natural, produced by the tendency of the local sandstone to fracture along regular planes due to its crystalline structure. Natural sandstone formations can and do produce right angles, flat surfaces, and parallel lines. The debate between these two positions has not been resolved. What remains unexplained is the sheer density and spatial coherence of the geometric features, which, even granting the natural fracturing argument, presents an unusual concentration of regular forms in a single location. What all three of these sites share, and what connects them to the broader argument of this documentary, is their timing. Doggerland was occupied and then drowned within the same broad period as the Younger Dryas aftermath and the construction of Göbekli Tepe. The structures at Dwarka, if the dating holds, were built within a few thousand years of the same window. The Yonaguni formations, if human-made, were last above sea level during or shortly after the Younger Dryas period. They are not isolated anomalies. They are data points in a pattern that the ocean has been slowly obscuring for the past 12,000 years. The technology to systematically survey submerged prehistoric landscapes now exists. Multi-beam sonar, remotely operated underwater vehicles, and improved underwater excavation techniques have advanced to a point where a serious, funded, international program of seafloor archaeology could begin to recover what the ocean has been keeping. Archaeologists have noted that the academic and financial infrastructure for such a program does not yet exist at anything close to the scale the problem demands. In the meantime, the ocean floor holds its silence. Somewhere beneath the Java Sea, beneath the Persian Gulf, beneath the continental shelves of every inhabited coastline on Earth, there are the remains of human lives and human communities that vanished not because civilization ended, but simply because the water came and did not go back down. They did not disappear because they failed. They disappeared because the world changed around them faster than memory could follow, and what we call the beginning of civilization may, in truth, be only the part that happened to be built on high enough ground to survive. There is a letter that was never sent. It was written on a clay tablet in the ancient city of Ugarit, on the coast of what is now northwestern Syria, sometime around 1180 years before the Common Era. The letter was addressed to the king of Alashia, the ancient name for Cyprus, and its contents are brief, desperate, and specific. He describes cities already burned. He asks for soldiers, for grain, for any help that can be sent. Before it could leave the city, Ugarit was destroyed. The city was never rebuilt. The language spoken there, Ugaritic, one of the earliest alphabetic writing systems ever developed, disappeared entirely. The palace, the temples, the merchant quarters, the sophisticated administrative infrastructure that had made Ugarit one of the wealthiest trading cities in the ancient Mediterranean. All of it ended within what the archaeological record suggests was a matter of years, possibly months. Above the destruction layer, There is nothing. No rebuilding, no new settlement, no continuity, just ash, and then silence. Ugarit was not alone. Between approximately 1200 and 1150 years before the Common Era, a window of roughly 50 years, something happened across the eastern Mediterranean that remains one of the most debated and most instructive catastrophes in all of recorded history. The Mycenaean palace civilization of Greece, which had produced the Linear B writing system and the great citadels at Mycenae, Tiryns, and Pylos, collapsed entirely. The Hittite Empire, which had been one of the dominant powers of the ancient Near East for 6 centuries and had fought Egypt to a standstill at the Battle of Kadesh, simply ceased to exist. Its capital at Hattusa in central Anatolia was burned and abandoned. The elaborate Bronze Age trading networks that had connected Egypt, the Levant, Anatolia, Cyprus, and the Aegean networks through which tin from Afghanistan, copper from Cyprus, grain from Egypt, and manufactured goods from across the region had flowed for centuries went silent. Egyptian texts from the reign of Ramesses III, carved into the walls of the mortuary temple at Medinet Habu near Luxor, describe a world coming apart at every seam simultaneously. Eric Klein, a professor of classics and anthropology at George Washington University and the author of the 2014 book 1177b, C. The Year Civilization Collapsed, has spent much of his career trying to understand what happened in those 50 years. His conclusion, developed through careful synthesis of the available archaeological, textual, and environmental evidence, is that no single cause can explain the Bronze Age collapse. What he describes instead is a perfect storm, a convergence of multiple stresses, each one manageable in isolation, that combined into a cascading systems failure that the interconnected civilizations of the late Bronze Age lacked the resilience to survive. The stresses Klein identifies are real and documented. Internal rebellions destabilized several palace economies. Trade route disruptions cut off the supply of tin, which was essential for the production of bronze, and had no local source in most of the affected regions without tin. Armies could not be equipped, which meant that states already under pressure lost their capacity to defend themselves precisely when defense was most needed. Earthquakes struck multiple sites in the Aegean and Eastern Mediterranean within a relatively short period, damaging infrastructure and displacing populations. And drought, severe, sustained, and widespread, appears to have struck the entire region during the same critical window. The drought evidence is not speculative. Brandon Drake, in a 2012 study published in the Journal of Archaeological Science, analyzed pollen records and marine sediment cores from sites across the eastern Mediterranean and found clear evidence of a significant reduction in precipitation beginning around 1200 years before the Common Era and persisting for several decades. Crop failures on that scale, sustained over multiple seasons across a region that was already operating on thin margins of surplus, would have set populations in motion, people moving away from unproductive land toward the coasts, toward whatever food sources remained accessible, creating the kind of large-scale population displacement that previous periods of stability had never required anyone to manage. This is where the Sea Peoples enter the story, and this is where the documented history begins to shade, at its edges, into something less certain. The Sea Peoples are depicted at Medinet Habu in some of the most vivid military reliefs ever carved in ancient Egypt. Ramesses III describes, in his own inscription, repelling multiple waves of invaders arriving by both land and sea confederations of groups identified by names that Egyptologists have been attempting to match to known ancient populations for over a century. The Peliset, widely believed to be the Philistines who later settled the Levantine coast. The Cheka, the Shekelesh, the Denyen, the Weshesh. Together these groups appear to have swept through Anatolia, the Levant, and Cyprus before being stopped at the Egyptian border, leaving destruction behind them at every documented point of contact. What remains unexplained is where they came from. Despite more than a century of serious scholarly effort, no archaeological culture has been definitively identified as the homeland of the Sea Peoples as a collective. One theory suggests they were not an invading force from outside the system, but a product of the collapse itself, displaced populations from the very civilizations that were disintegrating, people who had lost their cities, their harvests, and their social structures and were moving in desperation toward wherever stability still existed. In this reading, the Sea Peoples were not the cause of the Bronze Age collapse, but one of its most visible symptoms, refugees and opportunists filling the vacuum left by states that were already failing for other reasons. Another theory, supported by some linguistic and material culture evidence, suggests at least some of the Sea Peoples groups originated in the Aegean world, possibly displaced Mycenaeans, or affiliated populations set in motion by the same combination of drought, earthquake, and economic disruption that was simultaneously destroying their own civilization. If correct, this would mean that the collapse was in part self-consuming, the disintegration of one civilization generating the mobile force that helped accelerate the disintegration of the others. The final clay tablet from Ugarit sits in a museum now, its words still legible after more than 3,000 years. The king who wrote it never knew whether his message reached anyone. He never knew whether help was coming. He had no way of understanding that the world he was writing from, the interconnected, sophisticated, literate world of the late Bronze Age, was ending not just for his city but for every city he had ever traded with, every king he had ever corresponded with, every network of obligation and exchange that had held the known world together for centuries. What the Bronze Age collapse teaches, when examined with the full weight of its evidence, is a lesson that modern civilization has not fully absorbed. Complexity is not the same as resilience. A highly interconnected system, optimized for efficiency and growth, can be more vulnerable to cascading failure than a simpler, more redundant one, because every connection that makes the system productive in stable times becomes a pathway for disruption when conditions change. The late Bronze Age world traded across the entire Mediterranean. It depended on supply chains that spanned thousands of kilometers. It had built administrative and military systems that required continuous resource inputs to function. When multiple stressors hit simultaneously and those inputs were interrupted, the system did not bend. Within a generation, the writing systems were gone, the palace economies were gone, the long-distance trade networks were gone. The population levels across the affected regions dropped dramatically and did not recover for centuries. What emerged on the other side, the Iron Age world of smaller city-states, more localized economies, alphabetic writing systems accessible to more people, was in many ways a rebuilt civilization that had learned, at enormous cost, some of the lessons the collapse had to teach. Whether we have learned them yet is a question this documentary will return to before it is finished. There is a methodological assumption buried inside the way modern Western culture tends to treat ancient mythology, and it is worth naming directly before going any further. The assumption is that myth and data occupy separate categories, that a story passed down through generations is, by definition, less reliable than a measurement taken in a laboratory, and that the further back a tradition reaches, the less seriously it deserves to be taken as a record of actual events. That assumption is understandable. It is also, in specific and important cases, demonstrably wrong. The worldwide flood tradition is the clearest example of why. James George Fraser, the Scottish anthropologist whose comparative study Folklore in the Old Testament was published in 1919, catalogued flood traditions from cultures across every inhabited continent. His collection identified over 200 independent flood narratives, stories of a great inundation, a destruction of the known world by water, a survival of a remnant of humanity, and an eventual emergence into a renewed world. 200 traditions, drawn from Mesopotamia, Egypt, Greece, India, China, the indigenous cultures of North and South America, Polynesia, Australia, and Sub-Saharan Africa, cultures that had no documented contact with one another at the time their traditions were formed, languages with no common root, cosmological frameworks with no shared ancestry. The standard academic response to this convergence, for most of the 20th century, was to explain it as a reflection of universal human psychological patterns, the fear of water, the experience of local flooding, the narrative structure of destruction and renewal that appears useful for organizing communal identity and moral teaching. That explanation accounts for some of the convergence. It does not account for the specificity, because the flood traditions do not merely share the general shape of a great flood. They share details. In a striking number of independent traditions, Fraser noted this, and subsequent researchers have confirmed and extended the observation the surviving human remnant is a single family. The survival mechanism is a vessel of some kind, a boat or a container. The vessel comes to rest on a mountain or high ground. Birds are released to test whether dry land has appeared. The flood is preceded by a divine warning given to one individual who is instructed to preserve animal life as well as human life. These are not the broad strokes of a universal psychological archetype. These are the specific operational details of a survival protocol, and they appear, with variations, but with recognizable consistency, in traditions separated by oceans and millennia. The most ancient written version of the flood tradition is not the biblical account of Noah. It is the Gilgamesh flood narrative, preserved on what is known as Tablet 11 of the Epic of Gilgamesh, a text housed in the British Museum in London in a cuneiform copy dated to approximately 700 years before the Common Era, itself a copy of an older Babylonian version dating to approximately 2,100 years before the Common Era, which is itself believed to be a written transcription of an oral tradition of considerably greater antiquity. The Gilgamesh flood story describes a man named Utnapishtim instructed by a deity to build a vessel, load it with his family and with pairs of animals, survive a catastrophic flood that destroys all other life, and come to rest on a mountain. The parallels with the later biblical tradition are so precise, including the detail of releasing birds to test for dry land, that scholars have long recognized a direct transmission relationship between the two accounts, most likely through Israelite exposure to Babylonian culture during the 6th century before the Common Era exile in Babylon. But the transmission relationship between Gilgamesh and Genesis, while academically interesting, is not the most scientifically significant aspect of the flood tradition. What is scientifically significant is that the tradition appears to be pointing at real events that the geological record has now begun to confirm. In 1997, geologists William Ryan and Walter Pittman of Columbia University's Lamont Doherty Earth Observatory published a paper and subsequently a book titled Noah's Flood, proposing that the Black Sea Basin underwent a catastrophic flooding event approximately 7,600 years before the Common Era. Their evidence was drawn from sediment cores extracted from the Black Sea floor, which revealed a sharp boundary between freshwater lake sediments below and saltwater marine sediments above, a boundary consistent with a sudden massive inflow of saltwater from the Mediterranean through what is now the Bosphorus Strait. Ryan and Pittman proposed that as global sea levels rose following the end of the last ice age, the Mediterranean eventually reached a threshold at which it breached the land barrier, separating it from the lower-lying Black Sea basin, sending a continuous torrent of saltwater cascading into what had been a freshwater lake. The inflow, they estimated, would have continued for months or years, raising the water level in the Black Sea basin by approximately 15 centimeters per day, and ultimately expanding its shoreline by hundreds of kilometers in every direction, drowning an enormous area of previously inhabited land. The stratigraphy Ryan and Pittman documented is confirmed. The sharp freshwater to saltwater boundary in the Black Sea sediment record is not disputed. What remains genuinely debated is the rate and character of the inflow, whether it was the sudden catastrophic torrent their hypothesis describes, or a more gradual process spread over centuries that would have been dramatic but not instantaneous. Subsequent research, including work by Petko Dimitrov of the Bulgarian Academy of Sciences and others, has added complexity to the picture without resolving it definitively. What is not seriously disputed is that a very large area of previously inhabited Black Sea coastline was permanently inundated as sea levels rose, and that human communities living on those shores were displaced. The cultural memory connection, the idea that the Black Sea flood became the basis for the Mesopotamian flood tradition, remains a hypothesis rather than a confirmed conclusion. The geographic proximity is suggestive. The earliest written versions of the flood story emerge from cultures in the Tigris-Euphrates Valley, geographically adjacent to the Black Sea basin. One theory suggests that populations displaced by the Black Sea flooding migrated into Mesopotamia and brought the memory of the inundation with them, where it was preserved in oral tradition for millennia before being written down in the Gilgamesh narrative. This chain of transmission cannot be proven archaeologically, but it is coherent, geographically plausible, and consistent with what we know about how oral traditions preserve the memory of catastrophic events. Archaeologists have noted a broader pattern that extends well beyond the Black Sea hypothesis. The period between approximately 12,000 and 5,000 years before the Common Era saw sea level rise events of varying intensity occurring repeatedly as different sections of the remnant ice sheets collapsed. Each major pulse of sea level rise would have inundated coastlines, displaced populations, and created exactly the kind of sudden, traumatic, and community-destroying event that oral traditions are most reliable at preserving. The worldwide flood tradition may not be the memory of a single event. It may be the accumulated residue of dozens of flooding events occurring across different regions at different points within a several thousand-year window, all of them producing the same essential human experience: the water coming, the land disappearing, the desperate survival, and all of them eventually folding together through the compression that oral tradition naturally performs on historical memory into a single archetypal narrative of the Great Flood. What this means, if the interpretation is correct, is that the flood myths are not metaphors for the fear of water. They are not invented moral fables about divine punishment and human virtue. They are the oldest continuous dataset in human possession, a distributed, redundant, cross-cultural archive of real geological events, preserved not in stone or in clay, but in the most durable medium our species has ever developed. Passing a story to the next generation, asking them to remember, and to pass it on again. The story survived. The question is whether we are finally ready to read it as what it actually is. At some point in almost every documentary about ancient mysteries, lost civilizations, or unconventional archaeology, a particular kind of language appears. It usually arrives with a lowered voice and a knowing pause. Someone says that the establishment does not want you to know this, that the evidence has been buried, not by geological processes, but by institutions, by academic gatekeepers, by people with a vested interest in keeping the official story intact. The implication is that the truth is being actively hidden, and that the viewer is now among the privileged few being let in on what the experts have been concealing. This documentary is not going to do that. Not because the relationship between unconventional research and mainstream academia is always comfortable or fair, it frequently is not, but because the suppression narrative, in its popular form, is both inaccurate and ultimately harmful to the very inquiry it claims to be advancing. It substitutes the satisfying drama of conspiracy for the more demanding and more genuinely interesting work of understanding how knowledge actually changes. So, let us talk honestly about how knowledge actually changes. The dominant model in the history and philosophy of science, developed by Thomas Kuhn in his 1962 work, The Structure of Scientific Revolutions, describes scientific progress not as a smooth accumulation of facts, but as a series of paradigm shifts, periods of relative stability in which a dominant framework organizes research and interpretation, punctuated by crises in which anomalous evidence accumulates to the point where the old framework can no longer contain it, and a new one eventually replaces it. It involves resistance, debate, and genuine conflict between researchers who have invested careers in the existing framework and those proposing to overturn it. This is not conspiracy. This is the documented sociology of how human institutions, including scientific ones, actually behave. The history of American archaeology offers one of the most instructive examples available. For most of the 20th century, the dominant framework for understanding the peopling of the Americas was known as the Clovis First model. The model held that the earliest humans to arrive in the Americas were the makers of distinctive fluted stone projectile points, first identified near Clovis, New Mexico, in the 1930s. Clovis technology was dated to approximately 13,300 years ago, and the model proposed that these people had crossed from Siberia to Alaska via the Bering Land Bridge and moved rapidly southward through an ice-free corridor between the retreating Laurentide and Cordilleran ice sheets. Clovis First was not merely a hypothesis. It became the paradigm, the organizing framework within which American archaeology operated for decades. Archaeological sites that produced evidence of human presence predating Clovis were treated with deep skepticism. The burden of proof for any pre-Clovis claim was extraordinarily high, and the professional consequences for researchers who pursued such claims without ironclad evidence were real and documented. Tom Dillahay, an archaeologist then at the University of Kentucky, began excavating a site called Monte Verde in southern Chile in 1977. What he found there was evidence of human habitation dating to approximately 14,500 years ago, more than 1,000 years before Clovis. And located at the southern tip of South America, a geographic position that made the Bering Land Bridge entry route and subsequent southward migration timeline extremely difficult to reconcile. Delahaye's findings were rigorous. His documentation was meticulous. His methodology was sound by any reasonable standard. The mainstream archaeological community rejected his conclusions for nearly 2 decades. The resistance was not primarily driven by evidence. It was driven by paradigm protection, by the institutional difficulty of accepting findings that required the fundamental reorganization of an established framework. Individual researchers questioned his dating methods, his site stratigraphy, and his identification of certain materials as human-modified rather than naturally occurring. The criticisms were not always in good faith, and some of them were later acknowledged as motivated more by the desire to preserve the existing model than by genuine methodological concern. It was not until 1997, when a delegation of prominent archaeologists visited Monteverde and issued a formal statement accepting the site's pre-Clovis dates, that the paradigm began to shift. 20 years of legitimate, well-documented evidence had been required to overcome the inertia of an established framework. The Younger Dryas impact hypothesis followed a remarkably similar trajectory. When Richard Firestone and his colleagues published their initial paper in 2007, the response from parts of the geological and archaeological community was swift and skeptical. Critics argued that the platinum concentrations could be explained by volcanism. They questioned the identification of nanodiamonds and cosmic spherules at certain sites. They raised methodological concerns about sampling procedures. Some of the criticism was scientifically valid and led to genuine improvements in subsequent research. Some of it was, in retrospect, more reflexive than rigorous, a reaction to a hypothesis that threatened to complicate an established picture of gradual climate change rather than a dispassionate assessment of the evidence. By 2018, the hypothesis had gained sufficient supporting evidence from additional sites, improved analytical techniques, and the discovery of the Hiawatha crater that the tone of the debate within the scientific literature had shifted considerably. It had not achieved consensus. It remains contested. But it was no longer possible to dismiss it with the confidence that had characterized early objections. The pattern was identical to Monteverde. Legitimate evidence, institutional resistance, gradual acceptance as the evidence accumulated beyond the point where dismissal remained intellectually honest. What these cases demonstrate is something more nuanced and more useful than a suppression narrative. They demonstrate that scientific institutions have a genuine and documentable tendency toward conservatism, toward protecting established frameworks against challenges, even well-evidenced ones, because established frameworks represent the accumulated investment of careers, funding structures, and institutional reputations. This conservatism is not always malicious. It serves a real function. It prevents the field from being reorganized by every poorly supported claim that comes along. And there are many poorly supported claims, but it also means that genuinely important discoveries can spend years or decades in the wilderness of professional skepticism before receiving the serious engagement they deserve. One theory suggests that this institutional conservatism is actually more pronounced in fields like archaeology and geology than in the physical sciences. Because the evidentiary base is more interpretive, the same artifact or sediment layer can often be read in multiple ways, which gives paradigm-protective skepticism more legitimate-seeming purchase than it would have in a field where measurements are more directly decisive. The distinction that matters, the one that the popular suppression narrative consistently collapses, is the distinction between institutional conservatism and active concealment. Institutional conservatism is real, documented, and worth understanding. Active concealment of major archaeological or geological evidence by coordinated academic gatekeepers is not supported by the evidence. Academic institutions are not monolithic. They are composed of competing researchers with competing interests, operating across dozens of countries and hundreds of institutions, publishing in journals that are available to anyone. The history of archaeology does not show evidence being hidden. It shows evidence being disputed, delayed, and eventually, when it is genuinely strong, accepted. This matters for how we approach everything else in this documentary. The anomalies are real. The questions are genuine. The evidence for a more complex and more catastrophically interrupted human prehistory than the conventional timeline acknowledges is substantial and growing. None of it requires a conspiracy to explain. It requires something more demanding and more honest. A willingness to follow the evidence carefully, to distinguish between what is confirmed and what is hypothesized, to hold open questions with intellectual patience, rather than filling them prematurely with either establishment, dismissal, or alternative certainty. The truth, insofar as that word applies to an ongoing investigation rather than a settled conclusion, is not being hidden. It is being slowly, imperfectly, and sometimes frustratingly uncovered. That is how it has always worked. And understanding that process is not a concession to the establishment. It is the only reliable path to actually finding out what happened. Every year, in late October and again in late June, the Earth passes through a region of the inner solar system that is measurably different from the space on either side of it. The difference is not visible to the naked eye and produces no dramatic effect in most years. A modest increase in meteor activity, a few more shooting stars than usual in the pre-dawn sky, perhaps a fireball, reported somewhere over a populated area that makes the local news for a day and is then forgotten. Most people who have ever watched the Taurid meteor shower have done so without any awareness of what they were actually looking at. What they were looking at is the debris field of a disintegrating giant comet, a dispersed trail of rocky and metallic fragments, ranging in size from dust particles to objects several kilometers across, spread across an enormous arc of the inner solar system in a pattern that the Earth's orbital path intersects twice every year. The stream is named for the constellation Taurus, from which its meteors appear to radiate. Its existence is confirmed, mapped, and studied by planetary scientists at institutions around the world. And if a small number of researchers working at the intersection of astronomy, geology, and archaeology are correct, it has ended civilizations before. The intellectual foundation for this line of inquiry was laid primarily by two British astronomers working in the 1980s, Victor Klube of Oxford University and Bill Napier of the Armagh Observatory in Northern Ireland, published a series of papers and two books, The Cosmic Serpent in 1982 and The Cosmic Winter in 1990, that developed what they called the theory of coherent catastrophism. Their argument, developed from orbital mechanics and cometary physics, was that the inner solar system periodically receives giant comets from the outer solar system, objects potentially tens of kilometers across, that over centuries and millennia fragment under the gravitational and thermal stresses of repeated solar approaches into progressively smaller pieces. These fragments do not disappear. They spread along the original orbital path, creating debris streams that persist for thousands of years and that the Earth encounters on a predictable schedule. Klube and Napier proposed that the ancestor of the current Taurid stream was a giant comet that entered the inner solar system somewhere between 20,000 and 30,000 years ago and has been fragmenting ever since. The debris it left behind is not uniformly distributed. It is concentrated in swarms denser regions within the broader stream, and the Earth's passage through one of these swarms, rather than through the more diffuse background material of the stream, produces the conditions for a genuine bombardment event rather than a modest meteor shower. Their models suggested that such swarm encounters occur on cycles of approximately 3,000 years, with the most intense periods of bombardment clustered around specific windows in the orbital geometry. The Taurid stream itself is not a hypothesis. It is a confirmed, catalogued, and continuously studied structure in the inner solar system. The existence of near-Earth objects within the stream, including objects large enough to cause significant regional or global damage if they were to impact or airburst over a populated area, is likewise confirmed. The European Space Agency and NASA both maintain active monitoring programs for Taurid stream objects as part of their broader planetary defense responsibilities. The question that Klube, Napier, and subsequent researchers have been pursuing is not whether the stream contains dangerous objects. It does, but whether it has delivered catastrophic encounters in the historically and prehistorically recent past, and whether the timing of those encounters correlates with the archaeological and geological record of civilizational disruption. When the proposed swarm encounter windows from Klube and Napier's models are placed alongside the timeline of catastrophes examined in this documentary, the alignment is uncomfortable in its precision. The Younger Dryas onset at approximately 12,900 years ago falls within one proposed window of peak torrid stream activity, the widespread evidence of societal disruption and climate anomaly around 5,600 years ago. The period of the Black Sea flood and the collapse of several early Neolithic cultures in Europe and the Near East falls within another. The Bronze Age collapse of approximately 1,200 years before the Common Era falls within a third, and a proposed encounter window in the first millennium before the Common Era corresponds to a period of widespread cultural disruption across Eurasia that some historians have connected to climate anomalies recorded in tree ring and ice. Core data. Archaeologists have noted a clustering of catastrophe traditions in the mythological and religious literature of multiple cultures precisely at these proposed window periods. The Mesopotamian flood tradition, the Norse Fimbulwinter, the Greek myths of Phaethon, the son of the sun god who lost control of the solar chariot and scorched the earth before being struck down, and the widespread ancient association of comets with divine punishment and civilizational endings all appear concentrated in the cultural memory of the same narrow time windows. One theory suggests that the ancient astronomical traditions of Mesopotamia, Egypt, and China, all of which tracked cometary phenomena with considerable sophistication, were not merely academic exercises, but responses to a genuine and experienced pattern of periodic cosmic threat, an attempt to predict, and perhaps to warn against, the recurrence of something that had already happened within living or recent memory. The 2013 Chelyabinsk event provides a modern data point that is worth dwelling on for a moment. On the morning of February the 15th, 2013, a rocky object approximately 20 meters across entered the Earth's atmosphere over the southern Ural Mountains of Russia and exploded at an altitude of approximately 30 kilometers in an airburst event that released energy estimated at between 400 and 500 kilotons, roughly 30 times the energy of the atomic bomb dropped on Hiroshima. The explosion shattered windows across an area of thousands of square kilometers, injured approximately 1,600 people, and produced a pressure wave that was recorded by infrasound monitoring stations around the entire planet. The object was not detected before impact. No warning was issued. The most comprehensive global monitoring network in human history had no idea it was coming until it was already burning in the atmosphere. The Chelyabinsk object was, by planetary defense standards, small. The Younger Dryas impactor, whatever its precise nature, released energy orders of magnitude greater. The gap between these two events is not a reassurance. It is a reminder of the range of what the solar system is capable of delivering on timescales that human civilization has not yet experienced in its recorded history. What remains unexplained is the precise orbital structure of the denser swarms within the torrid stream and the exact timing of future peak encounter windows. Bill Napier, in a 2019 paper published in the journal Monthly Notices of the Royal Astronomical Society, updated his models with improved observational data and concluded that the Earth may be approaching a period of elevated torrid stream activity in the coming decades, potentially peaking sometime in the 2030s. His model suggests that during peak encounter periods, the probability of a Chelyabinsk scale or larger airburst event increases significantly above background rates. This is not a prediction of a specific impact event. It is a probabilistic assessment of elevated risk during a specific orbital window based on the best available models of stream structure and Earth orbit intersection geometry. The planetary defense community takes the torrid stream seriously. ESA's Planetary Defense Office and NASA's Planetary Defense Coordination Office both include torrid stream objects in their monitoring catalogs. The 2015 and 2019 close approaches of large torrid stream asteroids, designated 2015 TX24, and related objects, community for more intensive survey work on the stream's larger fragment population, most of which remains uncharacterized. What the ancient cultures that built Göbekli Tepe, that recorded the Younger Dryas catastrophe in myth and monument, and that preserved the flood tradition across 200 independent lines of transmission, may have understood in their own language, within their own conceptual framework, is something that modern planetary science is now confirming through orbital mechanics and telescopic survey. The sky is not static. It is not safe in any permanent sense. It moves through cycles that are long enough to exceed the span of any individual civilization's memory, but short enough to have struck within the period of human habitation on this planet multiple times. They encoded that knowledge in stone, in story, and in the careful observation of stars. They did so because they had experienced what happens when a civilization is caught unprepared, and they did not want the next generation to face the same morning without warning. Whether the next generation, which is us, is listening carefully enough, is a question that the orbital mechanics of the torrid stream will eventually answer. Independent of whether we choose to ask it, the Earth is not a passive object sitting quietly in space while the sun shines steadily upon it. It is a magnetically active planet, embedded in a continuously variable electromagnetic environment, orbiting a star that cycles through periods of relative calm and periods of intense energetic output on timescales ranging from 11 years to centuries to millennia. The interaction between the sun's variable output and the Earth's own magnetic field itself in continuous, slow motion determines, in ways that are only now being fully appreciated, the conditions under which life on this planet exists and under which civilizations are either protected or exposed. Most of the time, this interaction is invisible. The Earth's magnetosphere, the region of space dominated by the planet's magnetic field, deflects the continuous stream of charged particles flowing outward from the sun. The solar wind around the planet, rather than allowing it to strike the surface directly. The auroras visible at high latitudes are the visible signature of this deflection process, produced where solar particles enter the magnetosphere at the polar cusps and interact with atmospheric gases. Under normal conditions, the magnetosphere provides sufficient shielding that the surface of the Earth receives a manageable level of cosmic radiation, enough to drive some biological mutation and evolution over geological timescales, not enough to threaten complex life in the short term. But the magnetosphere is not a fixed structure. It fluctuates in strength and geometry in response to solar activity, and it undergoes much larger variations on longer timescales as the Earth's internal magnetic dynamo, driven by the circulation of molten iron in the outer core, changes its configuration. These longer-term changes include geomagnetic excursions, periods during which the magnetic field weakens dramatically and the magnetic poles wander far from their geographic positions, and full geomagnetic reversals, during which the north and south magnetic poles exchange positions entirely. Both excursions and reversals are documented in the geological record through the preserved magnetic orientation of volcanic rocks and ocean floor sediments, which record the direction and intensity of the ambient magnetic field at the time of their formation. The most thoroughly studied geomagnetic excursion within the recent geological record occurred approximately 42,000 years ago and is known as the reshaped excursion. During this event, the Earth's magnetic field weakened to approximately 6% of its current strength, not zero, but a reduction so severe that the magnetospheric shielding of the planet was dramatically compromised. The duration of the excursion, from initial weakening to recovery, spanned approximately 1,000 years, with the period of most extreme weakness lasting perhaps a few centuries. In 2021, a research team led by Alan Cooper of the South Australian Museum and Chris Turney of the University of New South Wales published a landmark study in the journal Science that drew together evidence from multiple independent sources: ancient kauri tree rings preserved in New Zealand peat bogs, ice cores from Greenland and Antarctica, and cave stalagmite records from across the world to reconstruct the environmental and biological conditions during the reshaped excursion with unprecedented precision. Their study, which named the event the Adams Transitional Geomagnetic Event in a reference to Douglas Adams, found that the period of magnetic field weakness correlated with a dramatic increase in cosmic radiation reaching the Earth's surface, a significant expansion of the ozone hole at middle latitudes, and a marked increase in atmospheric radiocarbon production, all consistent with the expected consequences of substantially reduced magnetospheric shielding. The biological correlations Cooper and Turney identified were striking. The reshaped excursion window corresponds closely with the extinction of the Neanderthals in Europe, and with a simultaneous explosion in the production of cave art by anatomically modern humans in the same region. The cave paintings of Lascaux in France and Altamira in Spain, among the most celebrated artistic achievements of prehistoric humanity, date to within the reshaped window. One theory suggests that the increased cosmic radiation during the excursion drove biological and neurological stress responses that manifested in heightened symbolic and creative behavior, or alternatively, that the Neanderthals, with their less flexible behavioral repertoire, were unable to adapt to the rapidly changing environmental conditions that the excursion produced, while modern humans, with their greater behavioral versatility, survived and recorded their experience on cave walls. What remains unexplained is the precise causal mechanism linking the geomagnetic excursion to the Neanderthal extinction. The correlation is real and the timing is close, but correlation does not establish causation, and the extinction of the Neanderthals likely involved multiple interacting factors, including competition with modern humans, climate stress, and population fragmentation. The Cooper and Turney study does not claim to have resolved this question. It claims to have identified a previously underappreciated environmental variable that deserves to be included in the analysis. The reason this matters for the present is that the Earth's magnetic field is currently weakening. This is not a fringe observation. It is a continuously monitored, publicly documented, and scientifically uncontested measurement. The European Space Agency's Swarm satellite constellation, launched in 2013 specifically to map the Earth's magnetic field with high precision, has confirmed that the field has been weakening at an average rate of approximately 5% per century over the past 170 years, the period over which systematic magnetic measurements have been available. More significantly, the South Atlantic anomaly, a region of unusually weak magnetic field strength centered over the South Atlantic Ocean between South America and Africa, has been growing in both area and intensity over the same observational period. Satellites passing through the South Atlantic anomaly regularly experience electronic disruptions and increased radiation exposure, and the region is considered a hazard zone for spacecraft operations. Whether the current weakening represents the beginning of a geomagnetic excursion or reversal, or merely a temporary fluctuation within the normal variability of the field, is genuinely unknown. The geological record suggests that full reversals occur on average every several 100,000 years, with the last full reversal, the Brunhes-Matuyama reversal, occurring approximately 780,000 years ago. By that average, the Earth is overdue. But geomagnetic reversals do not occur on a fixed schedule, and overdue in geological terms encompasses a range of uncertainty spanning hundreds of thousands of years. What the current observational data cannot tell us is whether the field will stabilize, recover, or continue weakening toward an excursion or reversal. What it can tell us is that a civilization as thoroughly dependent on electronic infrastructure as ours is uniquely vulnerable to the consequences of a significantly weakened magnetic field. The same solar particle events that the magnetosphere routinely deflects under current conditions would penetrate much further into the atmosphere and much closer to the surface during a period of substantially reduced field strength. The consequences for satellite networks, power grids, communication systems, and the semiconductor-based infrastructure that underlies virtually every aspect of modern economic life would be severe in ways that have no historical precedent, because no prior civilization has built its survival so completely on technologies that are sensitive to electromagnetic disruption. Solar Cycle 25. The current 11-year cycle of solar activity was initially forecast by NOAA and NASA to be a relatively modest cycle. That forecast was revised upward as the cycle developed more intensely than predicted. The cycle is expected to reach its peak activity solar maximum in the period around 2025 and 2026, coinciding with the window in which this documentary is being produced and watched. Solar maximum periods are characterized by increased frequency of solar flares and coronal mass ejections, eruptions of magnetized plasma from the solar surface that, when directed toward Earth, can compress the magnetosphere and drive geomagnetic storms capable of inducing damaging current surges in long conductor systems like power transmission lines. The precedent that most clearly illustrates the scale of this risk is not ancient. The Carrington event of September 1st and 2nd, 1859, named for the British astronomer Richard Carrington, who observed the solar flare that produced it, generated a geomagnetic storm so intense that telegraph systems across North America and Europe failed, simultaneously, in some cases shocking operators and setting telegraph paper on fire from induced currents even after the main power supplies had been disconnected. In 1859, The global telegraph network was the most sophisticated electronic infrastructure humanity had built. The damage was significant, but manageable. On July the 23rd, 2012, a coronal mass ejection of comparable or greater magnitude to the Carrington event erupted from the Sun and traveled through the inner solar system. NASA's Stereo-A spacecraft, positioned to observe the Sun from a different angle than Earth-based instruments, measured the event directly. The plasma cloud missed the Earth by approximately 9 days earlier in the Earth's orbit, and it would have struck directly. The estimated cost of the damage to modern infrastructure from a direct Carrington-scale strike has been calculated by various studies at between $1 and $2 trillion in the United States alone, with recovery timelines measured in years rather than weeks. The field that protects us was built over billions of years by the movement of iron in the Earth's core. The infrastructure it now needs to protect was built in approximately 150 years. The mismatch between those two timescales is not a reason for paralysis, but it is a reason for the kind of clear-eyed, evidence-based attention that ancient skywatchers, carving their warnings into the stones of Göbekli Tepe, were trying in their own way to encourage. The sky has always been both the source of life and the origin of the most serious threats our planet has faced. What has changed is not the sky. What has changed is how fragile the civilization sitting beneath it has become. Everything examined in this documentary up to this point has been, in one sense, history. The Younger Dryas impact happened 12,900 years ago. The Bronze Age collapse happened 3,000 years ago. The Reshaped excursion happened 42,000 years ago. The flood traditions were recorded by civilizations that no longer exist, in languages that took centuries of scholarship to decipher, on clay tablets and papyrus that survived by accident rather than design. It is possible to engage with all of that material with a certain comfortable distance, the intellectual pleasure of a deep mystery, the melancholy of lost worlds, the quiet satisfaction of pattern recognition across vast spans of time. That distance closes in this segment, because the convergence of risk factors that preceded every major civilizational disruption examined in this documentary is not purely historical. Several of its components are active right now, measurable in real time, and documented by the same scientific institutions whose evidence we have been drawing on throughout this story. This is not a prediction. It is a risk matrix, an honest accounting of what is currently known, what is currently developing, and what the historical record suggests about the consequences when multiple stressors converge simultaneously on a civilization that has not prepared for them. The first thread is the one we closed the previous segment with. Solar Cycle 25 is currently near or at its maximum, and it has exceeded the initial forecasts in intensity. The practical significance of this is not abstract. The global infrastructure that modern civilization depends on for food distribution, financial transactions, medical systems, water treatment, emergency communications, and virtually every other critical function is more thoroughly dependent on satellite and grid-connected electronic systems than at any previous point in history. A Carrington-scale coronal mass ejection striking the Earth during a period of elevated solar activity is not a theoretical worst case. It is, according to the risk assessments published by Lloyd's of London in 2013 and by the American Institute of Physics in subsequent years, a roughly 1 in 8 chance event over any given decade. Those are not apocalyptic odds. They are the kinds of odds that insurance actuaries take seriously and that infrastructure planners are obligated to plan for. The Quebec blackout of March the 13th, 1989, provides the most recent large-scale demonstration of what a significant geomagnetic storm can do to modern infrastructure. A coronal mass ejection of moderate intensity, substantially less powerful than the Carrington event, struck the Earth's magnetosphere and induced ground currents in the Hydro-Quebec power transmission network, severe enough to trip the system's protective relays in cascade. Within 90 seconds, the entire Quebec provincial grid went dark. The event caused transformer damage that took weeks to repair and produced northern lights visible as far south as Texas and Florida. The 1989 storm was not close to the upper limit of what the sun is capable of producing. The second thread is the torrid stream encounter window discussed in the previous segment. Bill Napier's updated orbital models, combined with the improved survey data on large torrid stream objects accumulated over the past decade, suggests that the Earth is entering a period of elevated encounter probability with the denser swarm regions of the stream. The specific timing of peak risk within any given encounter window cannot be predicted. With precision, the internal structure of the swarm is not yet fully characterized. What can be said is that the probability of a Chelyabinsk scale or larger airburst event is meaningfully elevated during swarm encounter periods relative to background rates, and that the background rate itself is higher than most people understand. The 2013 Chelyabinsk event was the largest known atmospheric impact since the Tunguska event of June the 30th, when an object estimated at between 50 and 80 meters across exploded over a remote region of Siberia and flattened approximately 2,000 square kilometers of forest. Had either the Chelyabinsk or Tunguska objects entered the atmosphere over a densely populated urban area, the casualty count would have been catastrophic. Neither was detected in advance. The third thread is the ongoing weakening of the Earth's magnetic field and the expansion of the South Atlantic anomaly documented by the ESA swarm mission. As discussed in the previous segment, the current rate of field weakening does not yet approach the extreme conditions of the Lachamp excursion, but it does mean that the baseline shielding provided by the magnetosphere is gradually diminishing, which incrementally increases the surface impact of any given solar particle event. The weakening and the solar maximum are not independent variables. They interact. A solar storm of a given intensity striking a planet with a weaker magnetic field produces more surface-level electromagnetic disruption than the same storm striking a planet with a stronger field. The two risk factors compound each other. The fourth thread is the one that is most difficult to quantify, but most important to understand. The structural fragility of the civilization that would need to absorb and recover from any of these events. The Bronze Age collapse, as Eric Klein documented, was not caused by any single catastrophe. It was caused by the interaction of multiple simultaneous stressors with a civilization that had optimized itself for efficiency and interconnection in a way that left it without the redundancy and local resilience needed to survive. Simultaneous shocks. The parallel with modern global civilization is not metaphorical. It is structural. Global supply chains for food, medicine, electronics, and energy are optimized to minimize redundancy, because redundancy costs money and efficiency generates profit. The just-in-time logistics systems that keep supermarket shelves stocked and hospital supply rooms functional depend on continuous, uninterrupted electronic communication and transportation networks. A serious disruption to those networks from a geomagnetic storm, from a regional conflict involving critical infrastructure, from any of several other identified risk categories, would propagate through the system in ways that are difficult to model and potentially very difficult to reverse quickly. What makes this moment historically distinctive is not that the risks are new. Most of the natural hazards in this risk matrix have existed throughout human history. What is new is the combination of their elevated probability, the solar maximum, the torrid stream window, the weakening magnetosphere, with the extraordinary complexity and interconnectedness of the civilization now exposed to them. The institutions that understand this are responding, quietly and without fanfare, in ways that are themselves historically significant. The Svalbard Global Seed Vault, built into the permafrost of a mountain on the Norwegian archipelago of Svalbard at approximately 78 degrees north latitude, was opened in February of 2008 and now holds over 1,300,000 seed samples, representing the agricultural biodiversity of virtually every food crop grown on Earth. Its location deep inside a mountain, in a region of stable permafrost, far from any major population center or likely conflict zone, was chosen specifically to maximize its survival probability across a wide range of civilizational disruption scenarios. It is, without anyone officially describing it as such, a backup for human agriculture against an event severe enough to destroy or damage seed repositories everywhere else. The Arctic World Archive, established in 2017 in a decommissioned coal mine in Svalbard, stores digital records on photosensitive film rated for 1,000-year preservation, cultural and historical records from dozens of nations, preserved in a format that does not require electronic infrastructure to read. The GitHub Arctic Code Vault, deposited in the same facility in 2020, contains a snapshot of all public code repositories on the platform, As of February of that year, the accumulated software knowledge of the current civilization preserved on film in a mountain in the Arctic. These are not the actions of institutions that believe the future is guaranteed. They are the actions of institutions that have quietly acknowledged, in the most practical terms available to them, that the continuity of the current civilization cannot be taken as given. They are building the equivalent of what the builders of Göbekli Tepe built: a deliberate preservation of accumulated knowledge in a form designed to survive whatever comes next, placed somewhere it is likely to be found by whoever comes after. Archaeologists have noted that every major civilization in the historical record that faced existential disruption gave some indication in its final years that it understood what was coming, even if it could not prevent it. The scribes of Ugarit were firing tablets for urgent dispatch in the hours before their city burned. The builders of Göbekli Tepe were filling their enclosures with soil and sealing them against a future they could not see. The Egyptian priests at Sais were preserving records of a catastrophe that had occurred 9,000 years before their own time, because they understood that the memory of what had happened was itself a form of protection against its recurrence. The parallel is uncomfortable. It is also precise. The people currently placing seeds and software and cultural records inside an Arctic mountain are performing the same act of civilizational preservation that the builders of Göbekli Tepe performed 11,000 years ago. They are doing it because they have read the risk matrix, and they have understood what it says, and they have decided that the responsible response is not to wait and see, but to ensure that something survives if the waiting produces the wrong answer. The question this raises, the one that this documentary cannot answer for you, but can only place in front of you, is whether the act of preservation is sufficient, or whether the historical record of civilizational collapse suggests that something more is required. Every civilization that built an archive and then disappeared had presumably believed that the archive was enough. The archive at Sais preserved the memory of Atlantis. It did not prevent the collapse of the civilization that kept it. What the record suggests, from the Younger Dryas to the Bronze Age collapse, from Göbekli Tepe to the last clay tablet of Ugarit, is that knowledge preserved in stone or on film or in permafrost is only the beginning of an adequate response. The rest of the response requires something that institutions are structurally less capable of providing: the willingness of a civilization, while it still has the capacity to act, to take seriously the evidence of what has happened before, and to build into its most critical systems. The resilience that history shows is the only reliable hedge against the convergence of forces that no single generation has ever successfully predicted, and that no generation has ever been fully prepared to survive. We began this story with a question. 5 civilizations, separated by oceans and millennia, all describing the same catastrophic day: fire from above, a darkened sun, rising water, the end of everything they had known. And the answer the evidence has slowly assembled is not comfortable, but it is honest. They were not writing mythology. They were writing the only news report available to them, pressing reed into clay, carving stone, singing the memory forward through generations, because they understood that forgetting was the second catastrophe, and in some ways the more dangerous one. What this documentary has traced, from the YDB layer buried in soil across 4 continents to the seeds sleeping in an Arctic mountain, is a single continuous thread. It runs from the survivors of the Younger Dryas, standing on higher ground watching a changed world settle into its new shape, through the builders of Göbekli Tepe, pressing 11,000 years of organized memory into limestone, through the scribes of Ugarit firing tablets that were never sent, through 200 independent flood traditions reaching across every ocean and every language barrier humanity has ever produced, and it arrives here, in this moment, in this conversation between the evidence and whoever is willing to sit with it long enough to let it speak. The thread is not a prophecy, it is a pattern. And patterns, unlike prophecies, do not require belief. Our ancestors were not primitive people stumbling toward the light of civilization. They were survivors of something that had already broken a more complex world than we previously imagined. And they spent the remainder of their lives doing the most sophisticated thing available to them, reaching forward through time toward people they would never meet, asking those people to remain awake to what had happened and to what could happen again. We are those people. We received the message. The question that remains, the one that no documentary and no evidence can answer on your behalf, is what we intend to do with it. The torrid stream crosses our orbit twice every year. The magnetic field is weakening in the measured, indifferent way that geology moves. The sun is near its maximum, and the infrastructure of modern civilization has never been more thoroughly dependent on systems that a single severe geomagnetic storm could interrupt in ways that would take years to repair. None of this announces a specific date. None of it is a countdown. It is, precisely as it has always been, a probability and a pattern available to anyone willing to look at it directly, without the comfortable distance that the word ancient usually provides. The last reset was not the end of the human story. It was the condition under which the human story, as we know it, became possible. What came after the darkness was Göbekli Tepe. What came after the flood was the first written word. What came after the Bronze Age collapse was the alphabet, the iron plough, and eventually everything built upon them. The builders of those recoveries were not extraordinary people. They were ordinary survivors who chose, in the aftermath of loss, to remember what mattered and to build again with whatever remained. That capacity has not left us. It is the oldest thing we carry,